Hello everyone, this is Sirisha Chimbili. I'm from the group 12 and our project is to do the comparative analysis of pre-trained encoders for emotion recognition in the text. The project basically focuses on detecting the emotions and categorizing them using the pre-trained encoders like BERT and RoBERTa and evaluate and compare these performance of the encoders. And we also worked on fine-tuning the selected pre-trained encoders to understand the contextual meaning and emotions of the data set. And through this, we have addressed some challenges like how well it generalizes the diverse emotional categories in the text, and it adds a lot of value to the society like as it empowers the AI assistants, which is a recent outcome, and also it helps in understanding and analyze the customer feedback, which helps in enhancing the user experience and customer satisfaction. It also improves the human machine interaction, and it also helps in the research, and basic research is always going on in the NLP to handle the sarcasm and using and improving the different models using the transformers. And the data set, we have collected the data set from the Hugging Face called Go Emotions. And this data set basically has 27 labels and neutral. And it all the size of it is more than 5K rows. And all the emotions we have scaled down into 6 categories as mentioned here and can be accessed through this link. And regarding the models, we have used BERT and RoBERTa, and we have used some tools like Beautiful Soup, Emoji, sklearn, Transformers from the Hugging Face, etc., and different techniques to handle the data and do the optimization and hyperparameter tuning of the model. So the project objective is to do the emotion detection of the text using BERT and RoBERTa and compare the performance between them. And the data has been collected from the Hugging Face co-emotions. And let's go through the data set first. And for this data set, we do have 28 emotions, including neutral emotion. As it is difficult to handle 28 emotions, we have simplified the approach by categorizing all the emotions into 6 categories. So this is the mapping file of all the emotions. So we have categorized like joy, amusement, gratitude, all into joy, and surprise realization into surprise, like this. And coming to the code, we have used the different libraries like Torch Vision, Hugging Phrase, Transformers, Emoji, etc. And we have imported all of them and basic like NumPy, Pandas, Matplotlib, etc. And we have loaded all the data, and these are the emotions, and we have mapped the index to the class, and we have made all the emotions into a list of classes by taking all these 6 emotions, and we've mapped all these emotions by making them zeros and mapping them again. And if you can see the train data, you can see that admiration has been mapped to joy, and gratitude has been mapped to joy, annoyance has been mapped to anger, like that. And we have done some pre-processing like contraction mapping, punctuation handling, and misspelled word handling, and by defining all the method for the specific cases. And we have used BERT tokenizer for BERT, and we have used 3 epochs and 32 as the batch size. We have used custom data set to take the ID of the text and token type of it, and then we've used BERT class to define the model and used the BERT model and did the hyper tuning for that, and we've used Adam optimizer for this. And then we have trained the model, and for 3 epochs and for 2 iterations for each epoch, we ran this training, and these are the losses of the average losses. You can see the improvement, and then we have validated the model using the test data, and these are our results. And we have plotted ROC curves and the classification report, AUC scores and all. And then the similar way for the RoBERTa, we have used RoBERTa tokenizer and same 3 epochs and 32 batch size, and created a custom dataset to read the data and loaded that and used RoBERTa class for it. And for this we have used auto model from pre-trained RoBERTa base, and we have calculated the loss by using Adam optimizer, and these are the losses. and validated using the test data set, and we have printed the metrics for this. And this you can see that ROC curves. This is the multi-label and multi-class classification. So this is the classification report of it. So you can see that RoBERTa has performed better than BERT, and still there are chances of improvement for this project. Coming to the evaluation methodology, we have used these metrics to evaluate the performance of the models, and these are the results of the classification report for BERT and RoBERTa. And we can observe that RoBERTa performed better than the BERT, and these are the ROC curves of the BERT and RoBERTa. To conclude this project, we worked on analyzing the pre-trained encoders on how to detect the emotions within the text. And these models performed really well competitively to each other, and but RoBERTa performed well than BERT. And we have done a comparative analysis of these for motion recognition. And we also explored on fine-tuning the methodologies of each encoder to optimize their performance. And these results and insights can be contributed for ongoing advancements in the NLP. Thank you.